How many pounds of nuts selling for 70 cents a pound must be mixed with 30 pounds of nuts selling at 90 cents a pound to make a mixture that will sell for 85 cents a pound?
Thank you. This is Sec 2. Very nice reading. 6-2. And we have different kind of nuts. They said nuts 1. And they mix with nuts 2. And they got nuts 3 or mixture. Without thinking, like robot, first of all, see which object participates in this problem. And create these objects. After that property, which unit they set? They set price and cents. They give you. You can write price, cents. What else do you know? They have pounds. And total value each in cents. Good idea to write unit of measure because sometimes they trick you. Instead of cents, they give doors. Instead of pounds, ounces, etc. Now, incorporate with data. You know, price of this 70. This is 90. This is given. And this 85. Okay. And they give you 30 pounds. This is 30 pounds. And ask you how many this one. They don't know, we don't know either. When you combine nuts 1 and nuts 2, you get 30 plus x, or x plus 30. And then you put in a jar this and this. You get more. Any questions so far? Nicole, using some browser, don't do this. And total value each. This is 70x. This is 90 times 30, which is 27 and 2 zeros. And this 85 times x plus 30. Usually there is simple logic. You combine two ingredients, this and this. You will get a mixture. So far, so good. So let's write it down. Equation 70x plus 2700 equals 85x. 85x plus 30. And make distributive property. You'll get 85x. 85x plus 2550. Let's solve it. Minus 70x and minus 70x minus 2550 and minus 2550. Cancel out. When you subtract, you get 150. And this would be what? 15x. And this you cancel out. When you divide by 15, x equals to 10 pounds. 10 pounds. And this would be my answer. Okay. It's like algorithm lead you to the target. Who understand this 100%? Raise your hand, students. What about Emma, KMD, Nicole? KMD, you understand this? KMD?
I have a question.
Yes, please.
How'd you get x plus 30? How'd you get x plus 30 for the mixture in pounds?
Look at this. Pretend you have a box. This box, right? This kind of box. And you have these nuts, X. After that, you added 30. I take the pink color. I added 30. This is 30. And I put on the scale. Pretend this is box is weightless, no weight. What I'll get on the scale if I have X and 30 mixture? You understand my question? You have in this box X pounds and you added 30.
X plus 30?
Yes, X plus 30.
Oh.
So easy, isn't it? Very logical. I like your question. So far, so good, can you?
Yes.
I can give another situation. For instance, they give you for everybody. Pretend this is 50 pounds. 50 pounds. And you took out X. Took out. How much is left? 50 minus X. You have two options. Either you add extra, you get add addition. Or you take some stuff. You subtract this. It's like your piggy bank. You have $50 and your small brother took out X dollars. What is left? 50 minus X. 100%? Yes, Kemje?
Yes, I understand.
Okay, who has more questions, student, for this? Yes, Matthew, you can. Now I have a question for everybody. Can you tell me why we have this problem? Is it related to life or this problem for SHSAT test or SAT test? Give me a situation when this problem makes sense in real life or has no sense in real life. Who can tell me? Explain the situation from real life situation. Anybody? Okay, put your hands down. Who thinks this is problem done for suffer small kids for SHSAT test only? Okay, some students think this was SHSAT test. Okay. Who think this problem can have sense for in real life? Okay, give me example. Give me a nice example. I want to feel from inside this math. Math is not just addition. You feel it, right? It's life. Who can tell me situation? In which situation? Yes? Go ahead.
When you are going to say Whole Foods or Trader Joe's and you have a mixture of nuts that you're buying and you need a certain amount of pistachios and almonds and raisins, you have to use this formula to put it
Yes,
together to weight.
very nice. When you have this one, very nice. It could be 100%. Any more ideas? Very good, A plus. Any more ideas, students? I'll give example. Another situation. Let's say you have this, pretend this kind of nuts is top quality, but very expensive, just a makeup. Very expensive. And this is not top quality, but cheaper. And some people, they don't like this because it's not top quality, but they like price. And they like it, but it's too expensive for them. Pretend it's $90 or $70. I just make some example. And what people in this store they do? They put, they combine put this in transparent boxes. You know this transparent. You open this, you see, oh, my favorite, nuts too. And just instead of $90, pretend this door to feel it better. It's only $85. I like it. And the result, they can trade these nuts eventually and make you more lucrative. It's related not only to nuts. If you see, sometimes they combine mixture of tea, different quality, everything. So many situations, it's taken from real life. They mix together. Good. Okay, so far so good. Let's go to problem number, it was 2. Number 3. Nicole, can you read number 3? It was your question as well.
Yes, sir. A container holds 10 pints of a solution which is 20% acid. If 3 quarts of pure acid are added to the container, what percent of the resulting mixture is acid?
Thank you. And these kind of questions use every time in our lab. We have labs where I make experiments. Okay. And this about solution. So let me make what they have. They have a few ingredients. They said solution, this 60. Solution 1. And we have pure acid. And you have mixture, you combine them. The first step, no thinking, just write what they give you. All schematic. Sometimes name the solution too long. And solution 1, it's no creative writing. So far so good. 3 objects. Properties. Always look what they're talking about. They have they're asking pints, right? What else? Percent of acid. Percent of acid. And what else? And pints of acid. Incorporate with data. In number 3, holds 10 pints. Put 10. Which is 20% acid. 20%, which is 0.20 or 0.2. I will see. Maybe add 0, maybe not. And they combine with pure acid, which is, where is it? Pure acid, 3 quarts. 3 quarts. Look at this. I can't put here 3 quarts because it's in pints. You know how to memorize all this stuff easily. I put here some for memorization. Pretend you have 1 gallon, which you do in 4th grade. 1 gallon. 1 gallon. And I split by there are 4 quarts. Quarts is 1/4. 1. So 1 gallon equals to 4 quarts. Or 1 quart equals 1/4 gallon. Now I cut it again by 2. And 1 quart equals 2 pints. 1 quart equals 2 pints. See this? If you compare this one and cut it again by 2, this is cups. And 1 quart equals to 4 cups, etc. So easy to memorize. What is my goal? To get this in pints. So since 1 quart is 2 pints, if I multiply everything by 3, I get 3 quarts. Why 3? Because this is given here. Equals to 6 pints. Sometimes we pronounce pints. This is 6. You always must convert to the same units what we have here. Any questions? No questions. As you asked me before, imagine I put here. We have a container. In this container, we had 6, 10 at the beginning. Pints. You added 6. How much is mixture? What is supposed to write here? Can you? Can you hear me? Raise your hand.
I can hear you.
If this was 10 and this is 6, what is supposed to write here?
60?
16.
16.
Add them up. My suggestion is you can't not now and see what they said. And this pure acid. What is pure acid? It means pure. It means only acid we have, which is 100%. You convert to number, you divide by 100. It would be 1. And mixture, they ask you, what concentration of mixture? I don't know. No, it's usually pint of acid. 0.2 times 10. This is 1 times 6. I just will be right. 1 times 6. And this is 16x. Well, you can make 0.2 times 10 is 2. 1 times 6 is 6. Okay, if you add them up, you will get this guy. So you can write 16x, they ask you what percentage, right? 16x equals 2 plus 6, which is 8. How to find x? Easy, divide by 16 both parts. By 16. Cancel, cancel. You can simplify like in 3rd grade, it would be 1 over 2. 1 over 2 is the same like 0.5. But look at this. This is number. How to convert number to percentage? Multiply by 100. And final answer, 0.5 times 100, you will get 50. 50 what? You get 50% of acid. 50%. Okay. Who understands this 100% up to this point? Raise hand. Lawrence, Emma. Who has questions? Who can give me a real situation? Why we do this in real life?
Can I say an example?
Sure.
So if you're using material that isn't acid, or like when you're making a medicine,
Yes.
you need to have like the specific amount of ingredients and like that perfect amount.
Makes
And
sense. Some ingredients you have to have different concentration, right?
yes.
I'll give example. Very good. I'll give example. Remember, I will not use this keyword which sometimes system block it, right? But remember, you have lockdown couple years ago, right? Remember, you were at home. Remember, everybody, and use some alcohol to wash your hands. Who remember this? Hand sanitizer, how you name it, right? And pretend you have. What is better, to have this alcohol 95% to fight bacteria, or 70% to fight bacteria? What do you think? 100% or 70%, for simplicity? Who thinks 100% is stronger, is better to use to fight bacteria? Raise your hand. Okay, majority, right? Who thinks 60? Who thinks 70 is better to fight bacteria? Some of you said 60. Prove your point. Who can prove your point? Nicole? Why do you think 70 is better than 100?
Sorry, I don't agree with that. I was just raising my hand because I forgot to lower it.
Okay, good. What can you? What do you think better? You're raising hand. 70 is better than 100 or not?
I think that's too much of a good thing is a bad thing.
Okay, this is very philosophical. You want to be a philosopher? Very philosophical, but more specifically, I'll tell you, even medical doctors make this mistake. I work with medical doctors. We have a company, Wall Street and Broadway, right? My company where I use medicals. So many of them think 100 is stronger and they fight bacteria better. It makes common sense, but this is wrong. Because when you have alcohol 100%, it evaporates so fast, that it's not enough time to fight this bacteria. But when you deliberately dilute it to 70%, it evaporates very slow. It has time to fight bacteria. That's when you go to any store and buy alcohol sanitizer, you never find 100%, never. 70 years, even 65. Make sense? Share with your friends. Nobody answered. They said, well, 100 is better. Well, it immediately evaporates. How it fight? Who understand this? And look at this, what in reality. This real situation. We had here 100%, and we added 20%, and we got what they need, let's say 50%. Real life. Okay? Yes, too much of a good thing is a bad thing. Yes, it philosophically sometimes yes, sometimes no. Let's say if you get 100% on this test, is it good or bad, Kemji?
It's a good thing.
It's a good thing. Yes. Makar, please. 6-5.
How much water must be evaporated from 240 pounds of a solution that is 3% alcohol to strengthen into a solution that is 5% alcohol?
Thank you very much. Good reading. And then 6-5. So what we have here in 6-5? We have solution 1. And when you must be evaporated solution of that alcohol. Okay, students, in reality, it's not necessarily 100% what is going on here from point of view of professional. I explained why I don't like this problem like 100%, okay? But so far, pretend this for test, what you know? We have solution 1. And they assume when you evaporate, when you pretend you put tea kettle in the water, right? Tea kettle with prepared tea for this, I don't know. tea kettle on the stove and this flame. And you see this evaporated water. They assume they are put on the stove water evaporated, not alcohol. In reality, it could be absolutely different, because if you study, if you look at the table, temperature evaporating of water and alcohol, other way around. But pretend people who are writing this test, they're not necessarily scientists, and they assume that water evaporating in all this question from this test. After water evaporating, you get solution which is not diluted, it's strengthened. Why? Because if amount of water decrease, solution will be stronger. So from professional point of view, it's not the best. But from point of view what they expect from you, try to study this algorithm. Now, what we have here, they have pounds, and you have, what is it, percent of alcohol, and pounds of alcohol. Usually when you're talking about real life, we measure alcohol in liters, milliliters, or ounces. But anyway, it's supposed to be consistent here. And what do you know? If it was 240 pounds of solution 1, and percent of alcohol was 3%, which is 0.03. And part of this water, I don't know how much water evaporates, let's say X pounds, goes with this steam, right? And water does not have any alcohol, right? But keep in mind, pretend in this we have 240 pounds, pretend gigantic tea kettle. And water goes out of this. It means the solution, what is left here, it will be 240 minus X, because it's not mixture. It's not diluting, it's strengthened. Water goes out. This is the thing. Be very careful. You add when you combine together, when water leaving this container, you subtract this. Who understand this stuff? This. After this, just the same mechanic. Good, good, good. Now, and what they said, this is supposed to be 5%, which is 0.05. How to get this? Is product of these two, 0.03 times 240. This is 0 times X. And this 0.05 times 240 minus X. Amount, not concentration, amount of alcohol before and after are supposed to be the same. So I can write this to the left, this to the, it doesn't matter, but more convenient when you have X to the left part, right? Some terms with X. 0.05 times 240 minus X equals 0.03 times 240. So far so good. I take different column and multiply both part by 100 to get rid of these decimals. I have 5 times 240 minus X equals 3 times 240. 3 times 240, 600, 120, 720. 5 times 240 is 1,200 minus 5x equals to 720. Any questions so far? Somebody wrote the question. No questions? Okay. Subtract on both sides. Minus 5x equals to negative 480. Divide by 5. If you divide by 5 both parts, by negative 5. You do instantly. Okay, what do we get? 96. 96 and unit of measurement is pounds. Okay. So look, analyze what you have. At the beginning, you have completely tea kettle, 200 pounds, gigantic tea kettle. We evaporated some water. It was concentration only 3%. When 96 pounds of this solution with alcohol left in this tea kettle, concentration increased tremendously, becomes 5%. Who can think in real life where you can use this approach? Any example? Okay.
I have an
Yes.
example.
Go ahead.
So, let's say you're making a tea.
Okay.
And you start boiling some water.
Yes.
Never mind. Let's say you have some dirty water and you're boiling it so that it gets cleaner.
Cleaner we use is procedure we name distillation for this case, right? Distillation. It's a little bit different story. I'll give another example. You know, everybody use salt, right? And there are different ways how to people get salt. In the mountains sometimes, or in the special lakes. Then they have salty water, right? And salty is not a salt. But when you evaporate water, concentration becomes, you strengthen bigger and bigger. It was, let's say, 7% of salt in the water, right? After that, you evaporate, becomes 50%. And etc. When there is no water, you get this powder. This get powder. And concentration would be what? Much stronger. You get rid of water, you increase your concentration. So keep in mind, on your test, it could be two different situations. If you add something diluted, or you evaporate